to discuss what's going on inside the package. I explained to you what are the forces or what are the energies, but let's see what are external processes, external forces working on the powder. And you have to know that your package is not uniform, and the way you pack the material will also have an effect on the tendency to aggregate or to lose the flowability. So now I want to show you how stresses are created in a package. We have to remember that powder is not a liquid. It doesn't transfer the pressure in the way liquid do. For example, if you see on the right, you see the pressure in a liquid container. And of course, it's very simple static pressure. You go down with the depth and you have the increase in pressure. Very simple. It doesn't look this way in a solid. When you have a solid, in that case, it's a conical shape, but let's ignore this for now. In a powder, what you have is that the walls are carrying part of the weight of the powder because of friction. So what we will see is an increase in pressure, but then it will remain constant. It will not grow anymore. And if we have a conical shape, it will even start to go down. And the reason for that, if you want to understand it, to visualize this, imagine a series of rows of arches that are made of bricks. And every time we have a particle touching this wall and this wall, they are kind of building an arch that holds part of the weight. And it means that if we are concerned about aggregation, about compressing of the material, our intuition would be to worry about what's going on in the bottom of the powder. It's not necessarily correct, which means that if you say, okay, I have aggregation, I have compaction of the material, let's fill the package only halfway, it will not necessarily help. And this is why, because the pressure is already the same. It's going, and if this pressure is enough to create compaction forces and solidification, then removing the, let's say, keeping the particles only, the package only this high will not make a difference. So the rule of thumb is that after 1/3 of the height, it's already the same. What we have to remember is that also the stress doesn't distribute evenly on the horizontal level, which means that if I have the wall of the package introducing pressure on this area, it will not go on the way to the center. So if you combine everything I said correct now, it means that the aggregation and the compaction may be created in a quite unexpected places. The last thing I would like to remind is that if I have a polyethylene liner used, and usually we are using it, and the operator is usually tight it very strongly and let's say tight with a plastic tie or with a rope, then what you have is that the polyethylene liner is applying constant pressure on the powder from the surroundings. And this, so it means that actually the compaction is because of the package and not because of the weight of the powder. What can we do with this phenomena? Okay, so when I talk about lumps and aggregates, we see them in a package material after some time. Sometimes it will be small lumps or small aggregates. Sometimes there will be large chunks, and sometimes, as you mentioned, we can get the entire package turning into a solid block. The thing to remember is that the lumps are not necessarily the bottom of the package. We will often find them around the walls of the vessel, of the package, and even floating at the top. And this is from two reasons. First of all, as I said, the polyethylene liner is creating the pressure also from the top, but also we'll see later that also aggregates can be levitated and flowing up to the top of the package. Another factors that increase lumping, temperature changes, as I mentioned in that description, how material get compressed and solidified because of flying in a cold condition. Impact and vibration, of course, if you keep it on a motor, if you take it in a truck, all these compaction, you know, back density, top density analysis, you know how compacted you can get the powder to be. So these are things we want to avoid as much as possible. So the tips I can give you for packaging are
Grazie. Ciao.
Yeah, first of all, I would advise to leave some headspace and not to tight the polyethylene liner because it creates a lot of pressure on the powder, especially if you have severe aggregation. We had one case, very extreme case, I remember, that we had a powder that was shipped in a very, very small containers, only like 1 kilogram container. But this 1 kilogram was turning into solid. Although, you know, there's no weight for the powder, it's very light, there is nothing inside, but still it was. And then we realized that most of the pressure was coming from the polyethylene liner. And in that case, we decided to give away, to not use the polyethylene liner, to put the material directly in a plastic box, and it really solved the problem. Because indeed, the polyethylene liner was applying most of the pressure. So if you have this problem of aggregation, look at all the things. Look at temperature changes, look at humidity. Maybe you should pack the powder in a very dry conditions. Look at tightening the polyethylene liner and look at your supply chain for avoiding vibration and sharp temperature changes. And as I said, small packages are not going to necessarily solve your problem.